Hey, Gabriella, how you doing? Here we go. We got a question right here. So when hey, Gabriella, how you doing? Here we go. We got a question right here. So when there we go. Turned off my audio. I had this from going. Error, load space, version check. There's no package. There's no package called. So what is the package saying? There's no package called that. Here, let me load up my R. And thank you for posting that error right here. There's no package called rlang. So it looks like you need to install the rlang package. So you need to install the rlang package. So what you want to do is you want to go, let me get it going over here on my computer. This is the way I fix this. And so other people are having this issue too. You want to go over here, go to the main screen. You want to load up R. So you want to load up R right here. So we're loading up R. So this is not RStudio, this is R. And with R loaded up, you want to do install dot packages rlang, and you want to run this right here. So install dot packages rlang. So it's probably going to ask me the CRAN repository I want to choose. I choose the USA Tennessee right there. So that's what you want to pick right there, and then install rlang. So that code, I'm not going to install it right here. That code is this. You want to quit out of RStudio. So you don't want to be in RStudio right now. So I'd need to quit out of RStudio. Don't save. And so you want to be inside over here inside of R. How's that looking right there, Gabriella? Gabriella, how's that look right there? And so I'm addressing this problem right here. I might message people in the Discord and say I'm covering this problem right now too. I am talking about, let me say to Chelsea, I am talking about installing rlang on YouTube office hours right now. So it's installing rlang. It's like the very start right here. So 1 minute, 20 seconds, installing rlang via R. So the important thing to know right here, and this is the way I've gotten the most success of having people do it, is to install it using R right here. So I'm installing inside of R right now. Install.packages rlang, quit out, and then quit out of RStudio. How's that looking, Gabriella, right there? So make sure you've quit out of it. So that should help with that issue. Let me know if you're having other issues. You can also post in the Discord your errors you're getting. We're working with people on fixing their errors, any errors they have. What issues are you having? And if you're here, feel free to say, hey, we are streaming right now, right? I think we are. Feel free to ask those questions in the chat, watching the chat right here. What other questions are there? We got 201, we got 320. The credit story about how do I just open R? Do you have a Mac or a PC? Mac or PC? Mac or PC? So it'll depend on how you, a PC. On the PC, you want to go to your Windows icon, click your Windows icon, and then go to the programs, and scroll down on your programs. So you want to go to your programs, and scroll down through your programs until you get to the R section. So you want to scroll down through your programs till you get to the R section right there. Scroll down through your programs right there. Let me know if you have a problem with it. Might have to meet, but you want to scroll down through your programs right there and get to the R section. And open up R 4.1.3, I think it is. Open up R right there. Tell me if you're having an issue. And so let me know how that's going. Opening back up RStudio. And then do the install. Found it? Nice. So make sure you've quit out of RStudio. And then you do the install.packages there, the rlang. What's this saying? It's saying some sort of object, partition, yarm, front matter not found. Weird. Weird. Go away, weird. Awesome. So make sure to install that. So people are saying over here, watching through the Discord. And join up the Discord if you haven't. People are asking about similar questions. People are having problems with the installation of the package. I think for some reason, the R language. Now you don't want to include these. Let me message that. Also, make sure to comment out any install packages in .rmd files since they won't knit. Try to address that so they don't have a problem. No. What questions are there? We got time here for 201, 320. What are people wondering about? Maybe I'll message 320 in their chat and say, hey, office hours live. People have questions. We're just talking through. We're just chilling out right now. If you have questions on the assignment, BAS 320. Let's see right here. If you have questions. If you have questions, join into office hours. A little bit of an advertisement right there. Try to get people to join in. How's it going, Gabriella, right there? Gabriella, going all right? I might take a look at some packages right here while we do this. Some of my favorite packages inside of R, the ggpub R. And I had a student doing GG Easy and doing GG Easy stuff that I didn't even know you could do. So ggpub R, really awesome package that does a really add summary. What? That's kind of cool. I should look what add summary does. Geom bracket. Here's all the GG plots that they have. GG donut chart. Okay, let's load up our data survey 10. And oh, we got to load reg class for that. I was like, you don't have reg class loaded. There we go. Data survey 10. If things don't autocomplete, then that tells you you don't have it loaded up. So we'll see how Gabrielle, if you have any issues, let me know. I'm going to do a GG donut chart here. So we're going to find out about this GG donut chart. Never done one before. See how it looks. They're showing how to run it. It's data and the X variable of interest. So we just need to put in our data frame. And they're doing some fills with colors and all this fun stuff right here with groups. So they're doing the values. Ooh, they're using like a frequency table for that. Huh, that's a bummer. That's going to be different than our data set. Well, there's the data frame. You see they have the frequency of the values. So they have a data frame with a frequency of values. I loaded it in the R console, but it has the warning message pop up. What warning message pops up? Hey, I'm in 320 with the professor. Can you talk about some important codes for coding day midterm? Sure, Raphael, let's do that. Here, we'll hop over to that. Let me look at this. I'm going to run this real quick, and then let's talk about coding day. Gabrielle, you might have to send me a screenshot, or we might have to hop onto a call or something to check this out, especially if you're on the Discord. The Discord, we can quickly take a look at it. We can hop into a screen share, and I can address that. Donut chart's not that cool. Donut chart's not that cool. Good to see you, Simone. And so let's take a look right here. Let's talk about some coding night right here. Let's hop over to the main screen. Okay, we're going to talk about some coding night stuff. Package R is not available for this version of R. And it looks like you spelled rlang properly. Shouldn't say that. We might have to take a look, Gabrielle. We might have to take a look. Also, make sure your R is up to date. Your R, run this r.version. Run r.version, and you have 4.2.1. When you run that code right there, do you get 4.2.1? It should say funny looking kid 4.2.1. And we're gonna talk about coding night right here. Coding night advice. Coding night advice, or BS 320, or coding advice. BS 320. Coding advice. All right, let's hop over to the main screen. Talk about some coding advice. Okay. So, yeah, and Gabrielle, we'll probably have to hop on a call or something. If jump on the Discord, I can quickly like call you up. Maybe in between office hours I could do it, or I could go on an intermission if you're on the Discord and like take a look. If I take a look at the screen, I can usually figure things out a lot faster. And if you're on the Discord, I can just jump in a call. Be like, boop, call. So we're giving some coding advice right here. And some of the stuff, hey, Trey, good to see you here. Some of the stuff we have right here can be done with a base data set. So what does it mean that something is base R? What does it mean that something is base R? Does anyone know what it means if I say base R? Like, think about the base level of something. What does it mean that something's base R? What does that mean? Like, the function mean is in base R. The mtcars dataset is a base R dataset. What does it mean that this is all base R? Like, sum is base R. You see summary is base R. What does base mean? Kind of important to know if someone says base R. What does that mean? And I can give you a hint by doing the following. Close out of R right here. And go back in and load back up our studio. Pretty much Shreya's got it right there. So base R means that the things we're working with, you don't have to load any additional packages. Does that make sense? Like these are the base things you have, like the basic. It's like the starter outers. So when I type mean, there's no package. And look, you see how nothing's coming up? They're all preloaded right here. So once I do, we had library ggplot. Libraries are going to be things that add on to R. So when I type mean now, look, we get all the ggplot2 things because the ggplot library is loaded up. So why do libraries exist? So Raphael and Simone right here with 320, why do libraries exist? Like, what is the point of a library? Why do we have libraries? Which I have tons of libraries. Library dplyr. Why do I have libraries? Why do I have libraries? I've got so many libraries. Why do I have these? Why do these exist? Why do you have libraries? What's the point? These are all my libraries. This is everything I can load right here. These are all the libraries I can choose from to load. See in 474, awesome, Shreya. Why do I have libraries? Exactly, codes or data sets or functions. They all, exactly, Raphael right there. They all give me things that are not available in base R. Does that make sense? So sometimes we run into issues, which is kind of funny right here. Which was one is it? Is it the mass? Shreya, I should be here for this. We were doing a function that was in the mass package, but also in another package. And so with this right here, all of these are available. And we had a problem where they were overlapping. This is how you view what's in a package. Like I could go to reg class and I can view what's inside reg class with this. Not super important, but we're going to focus on base R functions for a moment right here. So let's learn about base R. So when I say base R, what am I saying, Rafaela? What am I saying? If I say base R, I'm saying things that anyone who has R what? If I say we're learning about base R stuff right here, does that mean libraries are required? What does that mean if I say, let's talk about base R functions? That means the functions we're going to be talking about here are what? No libraries. These are all, everyone will have these no matter what. So mtcars is a data set that's loaded inside of R in base R. Like everyone has this. So what is a data frame? So my first question is, question one, what is a data frame? So I'm going to store this as data frame right there, and it's a data frame. So data frames look like this. What is a data frame? Think about how it looks. If I say a data frame, there's a lot we should talk about with it. If I say a data frame, what does it look like? There's a data frame. So I said store mtcars into df, because I'm calling it data frame right there. What is a data frame? Like conceptually, now we're about to do some codes with it. So first, what is a data frame? A data frame is basically like an Excel spreadsheet. Does that make sense? Does this look like Excel? A table, so a table is a table. And good answers, Raphael, right there. We're going to throw you some points. We throw points out here. Don't worry, they're just points for our class. We're having fun right here. We'll throw you the points button. Wait, here we go. There's the points button with the bonus. So a data frame is kind of like a table. It's a special object. You can find the class of an object by running class, and it's a data frame. There are things called tables where you could get a table of, let's say, the miles per gallon, and that is a table. So if you run the class on a table, that is a table. Does that make sense? So the class of an object, what does class mean? What does class mean? These are all really good ideas that are going to cement our understanding as we run different codes. So I asked, give me the class of the object df, and it said object df is a data frame. I said, give me the class of the table from data frame variable miles per gallon. Good to see you here. Can you have a third or fourth dimension? You can do lists and stuff. You could do matrices with multi-dimension. I don't think you can. Tell me if you can. Look, if you want to Google that real quick, tell me if you can. That's such a good question. I don't think we can have a third dimension. Like you could try. There might be a way. It is returning a value, but I don't think it's meant to be. But yeah, tell me what you think right there with the coding language. Yeah, if there might be a way to do 3 and 4 dimensional. You'd probably do a list at that point. You probably do a list because you go here and go list, df, and iris, and whoops, iris is lowercase. And that would put, so we could store this into a list right here. And there's the list. So the list now has kind of almost three-dimensional because you've got kind of the list, and then you've got the first thing in it, which is going to have rows and columns in the second. So you could do that. So what is going to happen if I run class on the list? So Raffaella, what's going to happen if I run class on the list? What is it going to tell me? What does class do? And what is that going to tell me when I run class on list? Hint, I kind of called it what it is. And then we'll talk about what class is, because that's super important. It's like the basal understanding. So what is it going to tell me when I run class on list? So class tells you how R sees an object. That's what the class of something is. Like R views it as this. Like if I look at this, I say, this is calling device. This is drinking device. That is how my brain recognizes the class of it. R looks at this object called list, or we could call it object 1. And when it looks at object 1, it says object 1 is a list. Does that make sense? How it's telling me what it sees it as. You can see that it's a list right there because I called it a list. Oh, nice. Thank you so much. Yeah, I thought they were. So, and we had you as a mod, Raffaella. Awesome work right there. So class lets us know how something is seen. How would the number 2 be seen as R? 2 is it's a number, right? So think about this. R sees 2 as numeric. Does that make sense? How does R see the word high? How does R looks at that and says, that's a what? It's how it understands it. Like it understands that 5 is a number. It understands, like we're saying, R, how do you look at the object 99? It says, oh, I see that as a number. I view that as a number and I'll manipulate it later in algorithms or functions as a number. How would it look at the word high? And notice the color change right here, which is very important. All of this, we're starting at a very base level understanding right here to build upon. This is a different object right here. The object high is different from the object 99 because the object high is viewed as a what? And the color change is important. Character, boom, it's a character right there. Exactly. That means words, character string sometimes in other languages. Or that's just the short, like character string. String is words. So it views it as that. So with this right here, let's go to a data set and look at the iris data set. The iris data set is a data set of flowers. I'm going to zoom out a little bit here so you can see it. It's just flower measurements and species of flowers. So these are known as what's inside the data frame. And great work right there, Raffaella. And good to see you here, DD, too. So what are these known as inside of a data frame? These are known as what's inside data frames. Just think of the way they look. They look like this. Now, they're columns. We could call them columns. But they're variables. And another V word I like to say, they're the what's inside of a data frame. And you can see them right there. They're variables. That's a good word for them, too. They're the variables. There's 5 variables inside the data frame. And how do you get to the variables in a data frame, which is a very important thing we need to know. How do you access a variable inside of a data frame? Like you've got a data frame here. You got the iris data frame and you want to get to a variable. You're like, man, I'd really like to pull a variable from this data frame. Like I got my iris data frame, but I want to pull a variable. And the hint is over here on the side. So you want to pull a variable from that data frame. So you want to be like, let me get a variable. How would you pull a variable? So let's say here, working with data frames. $, and look at that, we get the autocomplete right there. So once you type the $, you can get the variable. Now, this is a vector. It's the variable. It's the column we just saw a second ago. But this column is a numeric column. But not all things are numeric. Sometimes we have a variable that is categorical. Things that are categorical are known as what inside of R. Things that are categorical are known as what inside of R. Things that are categorical are known as what inside of R. Things that are categorical are known as what? If it's a categorical variable, we'll just call it this. So if it's a categorical variable, R sees it as a what thing. It says, oh, that's a this. That's how R sees factors. So why is class so important? Well, summary is a function that summarizes something for you. So when we summarize a quantitative variable, we get the 5-number summary, which is the first one right there. That's the quantitative vector. But when we summarize a categorical variable, we get a table. So class is very important because some functions work differently or only work with certain classes of object. If I say, here's some numbers, summarize them, it gives me the 5-number summary plus the mean. If I say, here's some categories, summarize the categories, it tells me how many observations are in each category. So this is a table right here. So this code right here is analogous to just running table on this, and you would get the same result, virtually a little space right there extra. But that's why class is so important, because the class of an object is how R sees it, and a lot of codes run differently on different or won't run on certain classes of objects. So when we're working with data frames right here, a data frame, and Didi said it a second ago, has how many dimensions? How many dimensions does a data frame have? How many dimensions does a data frame have? A data frame like Iris right here has how many dimensions? 2 dimensions, which means we have a row space and we have a column space. If I wanted to only look at the first row, what would I fill out inside of here? Like, how would the code look? Try to write the code for me that just returns the first row of this. Run the code that just returns the first row. Like, just show me the first row. Like, I just want to see the first row of the Iris data frame. How would I do it with the row and column space? Just remember, I want to rock. How would I look at just the first row? Exactly, Iris 1. If you leave columns blank, you get all the columns. So we're just going to leave that space blank. And then we're going to add 1 right there, and there's the first row. We'll make it a little bit wider here so it's more apparent that we're showing the first row. And there you go right there, there's the first row. Now what you can actually do is you can select multiple rows by concatenating. Concatenating makes a vector of numbers. So you could select different rows right here. Can we? Yeah, I'll look at that here in a second, Kyle. You got it. Notice right here, this is a vector of numbers. So let's put right here. We'll do 5-10 more minutes of this. And Rafaela, ask any questions you have. I'm hoping this helps. How do we create vectors? So if I said create the vectors of numbers 8, 10, 1, how would you do that, Rafaela? How would you create the vector of numbers 8, 10, 1? Like I want a vector of numbers. Just I want them put into a vector. Like here's my things, 8, 10, 1. How do we vectorize numbers? Like turn them into a vector. How do we create vectors? Our own custom vectors. How do we create our own custom vectors? 8, 10, 1. Close. You have to concatenate them. Concatenate's like the glue. So you go concatenate 8, 10, 1, and that kind of glues them together. So watch this. You ready? Here we go with a data frame. I'm going to make a fake data frame here. So we're going to go data frame, store into data frame. So I'm creating a data frame. We'll call it variable 1 is equal to this. Variable 2 is equal to D, B, E. Damn, brown Emily. Yeah, we got some 471 we're going to do soon here. And so take a look. Look at my data frame. Do you see this is my vector 1 right here? And this is my vector 2. Does that make sense? Now, vector 2 is actually not a factor. It's strings. But I have store into data frame, store into DF, a data frame where variable 1 is 8, 10, 1. There it is right there. And variable 2 is equal to DBE. If you wanted to turn variable 2 into a factor, we just wrap this inside of a factor right here. And now variable 2 is going to be a factor over here. It doesn't look very different, but variable 2 is now a factor. Like if I summarize it, it'll summarize as a factor versus a string right here. So that's a little bit more advanced right there. Let's do, I'm going to put a 5-minute timer on. What else are you wondering about? What do you want me to work with? What do you want me to explain? We could do an LM here, but what would you like me to talk about more? Like it's important to understand, like this is row 2, column 1. So if I go to my data frame and go data frame, row 2, column 1, it's going to return 10 right there, which is the value we just saw right there, row 2, column 1. So I can return that value. I could return everything but row 2. So if I want to say everything but row 2, I could do this, and there's all the data but row 2. So that's everything except row 2 returned to the screen. So understanding kind of how to work with these and the square brackets return positions is very important. Functions like the mean use parentheses. So this would be the mean of these numbers right there. And I've created my own vector inside of it. We got a few more minutes on the clock right here, but what else are you wondering about for 320 with coding? This is the basics right here. I started sort of from the very beginning, but let me know if something you're wondering about. I'm trying to think of what else to talk about, like basics wise. A lot of functions we have can be done on simple vectors like standard deviation, IQR, range, median, quantiles. A lot of these functions right here can be done on just simple vectors. More about how to get the summary and look into the test, where to make the RMSE, the R squared. So to get those concepts right there, so running regression, getting RMSE, R squared, and interpreting. Okay. And I have a really good video from this, I think from Monday. Check it out. One of the recent office hours videos, we went and we explained the full summary output. So to make a model, we need to run what? So there is a basic format to make a linear model called y tilde x comma data equals. So this is your basic format. This won't run. So this is y tilde x comma data equals. Does that make sense conceptually? Y tilde x comma data equals. Now I like to run a function here called names on a data frame because this gives me the names of the what's. This gives me the names of the what's in the data frame. This gives me the names of the what's in the data frame. What does that give me? Names gives me the names of the what in a data frame. If we look at the mtcars data frame, names gives me the names of the what's. Like, why would I run a function like names? And look at the output, and look at the output up here. What does... Yeah, we're about to get the report here in a second. So yeah, we're right about to get that, Rafaela. Good question. So why do I run names? That tells me the names of the what's. You said you had it earlier. You got it. Names is a great function because it gives you the names of the what's. We can see them up there, and we can see them down there. Names of the variables. Yep. So watch this. When I write my function right here, I'm going to take my basic format and say, I want to predict miles per gallon from the horsepower of a car from the mtcars data frame. Does that make sense what I'm doing right here? I'm saying this is the variable. We're not going to put it in quotes. It's going to be not in quotes. Y tilde x comma data equals. Oh, we'll look at some predicting too here. So we have the y variable of interest, the x variable explaining, and the data frame that these variables are contained inside of. How does that look right there? The y variable of interest is miles per gallon. The x variable explaining miles per gallon is horsepower, and the data frame that the variables are inside of is the mtcars data frame. This is your basic format right here, and this is with the context of the problem right here, so solving for one model. Now, everything we've done right here is created inside of M. M is now an object which contains a lot of stuff. It's actually a list that contains a bunch of things like our residuals, our coefficients, all this stuff right here. You could go through M and look at these things individually. I don't highly suggest doing it, but you could always do it if you wanted to, like looking at your residuals and such by going through your model here and getting these values like the predicted values. So the best thing I like to do is to manipulate the object M. And there's a ton of ways to do this. Probably most importantly is going to be the summary. Oops, trying to go to a new line right here with this. There we go. The summary summarizes the model for us. It does what it says it does. And the model is the linear model, which we can get via visualize model. So here is the linear model, if you make your figure wide enough, and there is the summary of the model. Any questions right now, Rafaela? What are you thinking right now? Let me know. But there is the linear model. I'm going to zoom out a little bit so the linear model is a little easier to see. I'm going to re-summarize on the screen. And here is the intercept of the linear model, which is going further back off the screen. Here's the slope, which is negative. There is the R squared value, which is 60.24%. There's the typical miss the model makes, which is 3.86 units. Usually it's off on the miles per gallon. And so there is our model, our estimates, and the visualization of our model all found by getting the estimates of the model via the summary and the visualization of the model with the visualized model right there. So there's a lot of ways we can go. Awesome, Raphael. That's good to hear. So to make predictions with the model, if you want to do new data, like we want to predict a car with 400 horsepower, we have to make our own personal data frame right here. Whoops, not data class. Data frame is going to be the function we use and say horsepower is equal to, and we pick the value we want. If you have multiple values, you need to put in the values into a vector, and you will create your own data frame. The data frame will have inside of it the variable you're trying to predict, which is the x variable of interest, or not of interest, the x variable to predict the y variable of interest. So now that we have our data frame, we can predict using our model. Predicting using the model will just make predictions for the data it already has, unless we add an argument called new data equals and we insert our data frame. Now it'll make predictions for the miles per gallon of the first car and make a prediction for the miles per gallon of the second car in the order they're input. So the prediction for the first car is 300. For a car that has 300 horsepower, it is predicted to get 9.6 miles per gallon. The second car, which is 400 horsepower, is predicted to get 2.8 miles per gallon. Now, additionally, with the predict function, you could do interval equals and get intervals here. You can get a prediction interval, or you can get a confidence interval. The prediction interval is the wider interval, which is the more uncertain interval for one individual. Notice how this one goes negative. That's probably because it's an extrapolation of our model going well beyond what we should be predicting. So we would expect a car that has 300 horsepower, a singular car, to get somewhere between 1 to 18 miles per gallon. But this is the mean of all cars because it's a confidence interval, confidence for the mean. So we would expect all cars that have 300 horsepower to get somewhere between 6.16 to 13.1 miles per gallon on average with 95% confidence. You can also change the level of this interval right here to something like 10%. I wouldn't do that, but you notice the interval is a lot tighter now, or we could change it back to its original 95 to be 95% confident the true mean is contained in the interval, which is the mean of the line. So the mean is the confidence interval, which is the tighter interval, and the prediction interval is the wider interval, and that is the one over there. So that is how we do predictions right here, and there's lots of other great things we can do by just manipulating the object M with things like check regression to check it. Would you still multiply by 2 to get the spread, or am I mixing concepts? Kind of, sort. So it's similar. You might be thinking about the RMSE. The RMSE right here of 3.863. You don't really I think I know what I think you're thinking of. So you're talking about the confidence for it. The confidence are going to be the confidence intervals for the coefficients in the model. So this is different than the prediction and confidence intervals for estimates or for predictions for the model, because this is intervals to estimate the coefficients of the model. So I am 95% confident the true intercept is contained in this interval. I am 95% confident the true slope is contained in the interval. And so if you notice, you could take the intercept and go plus 2 times the standard error, and that will basically get you the upper bound of a 95% confidence interval for the intercept. Because generally speaking, 2 standard errors is the distance we go for a 95% confidence interval. That is for the estimate of the intercept when we use confident. And if you look at the output right here, it's showing 95% between here. So the default for this is 95% for the level of this. You could change it though. You could go to 68, and then the answer should be about 31.7. 31.7. How did I know that? So how did Rafaela, do you know how I knew 31.7 would be the answer? How did I guesstimate 31.7? This is actually the empirical rule for 201, because 68% confidence intervals are generally how many standard errors above the mean. 68% confidence intervals are generally 1 standard error. So 95 are 2, and 99.7, there's the bell right there, 99.73 rather. No, it's a small data set. It's going to be interesting. So that's going to be about 35.1, 35.4. Darn it. It's weird when you go out towards the ends of the curve. Guesstimates. How's that? Is that making sense? These are intervals to estimate with 99.7% confidence the true intercept, 99.7% confidence the true slope of the line. So those are intervals to estimate. Awesome, Rafaela. Good news right there. We're going to do some 474. Check it out. Thank you so much, 320 swinging by. Always ask those questions. Let us know what you're working on. Ask those questions. How do I code this? What does this mean? How do we do this? We got some 474 questions right here. 1H. We got 1H, and I thought I saw another one. 1H, and I swear there was another one. 1H. Ugh. ES 474 1H. Assignment market basket. 1H. Okay. Let me get the assignment up and going right here. Modules. 1C and D. Awesome. We should do those first then. 1C, 1D. Might have to work with different data sets. Might have to work with different data sets. Thank you, Justin, right there. Let's throw Justin 1,000 points for helping out and answering what people wondered about. Okay. Assignments. We're going to get this assignment up and going. Association roles. Downloading the RMD. Okay. Let's head over to the main screen. Let's do this. Okay. 3703. So we got right here, we can jump right down to it. 1C. 1C asks, build a rule set using the support 80 divided by 118 or 108, 1,821, and a minimum level of confidence of 60%. Do not put any restrictions on the length of rules. Remove any redundant and non-significant rules. There should be this many rules left over. Then print out the top 10 rules in terms of lift to the screen. Hint. So we want to print out basically sorted by lift. So we're going to use the grocery data set for this. I'm going to use a totally different data set and do similar stuff. What function do we need to run to get rules? First off, you want to know what function are you running to get rules? What function do you need to run to get rules? So who knows what function we run to get rules? What is the function we run to get rules? How do we create rules? What function is run? A priori. Yep, great job right there, Justin. We run the a priori function. So let's go ahead and grab and look at some code right here. I always get the a priori wrong. Nope, we don't have it in this one. I'm going to go grab the thing over here. I got so many things open. Okay, let's take a look. So the a priori function. Where's my a priori? A priori. Here we go. The a priori takes a list of your conditions. So if you take a look and look what we got right here. And so everyone, I think, should have access to the solutions file right now to the activity. But look, removing out redundant rules. So this says go inside of the rules, and we want the rules that are not redundant. So is redundant checks if a rule is redundant. We don't want the redundant. Like if redundant was true, then we'd get only the redundant rules. What we want is not a redundant rule. And then we want is significant, and it's going to use the code right there. So we're going to get this right here, and we're going to run parts of these codes over here. So let's go back. So we're going to make some rules right here, but we need our data. I don't have the transaction data yet. Well, I think actually we have it in here to make it. Let me clear out my environment, and let's run it. Now we should get transaction data. Okay, there's the transaction data set right there. And let's take a look at the a priori function. Where'd it go? There it is. So the a priori function right here takes for the parameters a list. This is because we're entering in multiple things right here. So if you look at the sub-indent, I really like sub-indenting stuff. I started doing that a while ago, and it's helped me read my code a lot better. Because if you look at this, the first argument taken right here in a priori is your what. What is that? That's your what data. The first argument taken right here is your what data. Inside a priori, because you can make rules from it. The first argument taken inside of a priori is your what. Arguments are separated by commas. The first argument taken inside of a priori is your what. the transaction data. Then the next thing you do is you say parameter, which is the name of the argument, and then you say equals to a list. Now the list is going to be the conditions you're putting on this. So we are going to put conditions on this saying we need to have at least this support and we need to have at least this confidence. Does that make sense how to use it? Like, is this making sense for your example? Where you would say, I want there to be at least this support. I want there to be at least this confidence. And so you need to put in your support, your confidence, and then it'll run it that way. The last thing here, verbose control equals list. We actually don't even really need this. I mean, you might throw it on there, but it's not needed. It just shows you output if you don't have it on there. So the control, I guess you could change other things with it too, but now you see it doesn't show output. So the only difference between the first and the second time is first time I ran it, I didn't have that. It shows just some verbose like blah, 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 and it tells me a bunch of stuff, which doesn't matter. It doesn't matter. And the second time I put the control equals list, verbose equals false is the controlling the way it runs and turning the verbose, which is how much it talks to me, off. So that, once again, doesn't really matter. What matters more is we gave it the data. We said, do it this way. So now I've created the rules. Problem is sometimes you get redundant rules. And to remove the redundant rules, we're going to overwrite the rules by going inside of the rules and running the code is redundant, which is an a rules function. Is.redundant is an a rules function to find redundant rules. So finds redundant rules as it says. So let's remove out the redundant rules. Boop. And then let's only find the significant rules by running inside the rules because we're going inside of an object with the square brackets. And we're saying go inside of it and run the is significant by looking at the rules and the transaction data to only give me the significant rules. So we can find out how many rules we have by going to the length of rules, and yours should turn out the right way. So make sure you get your right amount of rules. Now, when you inspect the rules, is where I got to check. Inspect the rules. Inspect is a final thing that is done. Inspecting something is just going to show you, it's going to print to the screen rather, and you can't manipulate once you inspect. So once you inspect, it'll print to the screen and you can't change anything. So you can't go outside of the inspect and go 1 to 10, it'll still print to the screen and then run the 1 to 10 object afterwards. Pretty sure that we can go right here though and drop the 1 to 10 inside of it right here and get the first 10 rules. So you need to do everything you want inside of the inspect rather than putting things outside of it. Inspect will print to the screen. It's a function that prints everything to the screen. You can't put the stuff on the outside of inspect like, oh, I want the top 10 of these. No. That needs to be done inside the inspect. So we need to then sort, if we're going to sort these rules by something like lift right here, which is all the way here on this other side of the screen, we're going to have to do it inside the inspect. And this is where I'm going to check my knowledge. I might even have to use the notes to cheat right here. Okay, let's sort these rules. Okay. So we should be able to go to sort, right? See, the easy thing to do is just click your rules and you can view it. I'm not going to show me my rules. We go to inspect and store it. Store it as data frame. And now we could no as dot data frame. I know I've done this before. I think if you do it watch this, no joke, watch this. You do it again. I know it's done it. Maybe it's stopped doing it. You can use inspect on a subset of rules. Yes. Well, like the inspect is the final thing that is done. The inspect is the final thing that is done. Maybe I dreamed that up, that's stored. So the inspect is the final thing that is done. I swear I know it did it one day. The inspect is the final thing that is done. So we're going to go here to the rules. Let's go to sort. Cool, it's not mad. And I might have to look. I'm trying to remember how to do it with the sort. I need to pull up the notes. Or maybe it's in the sorting the rules is always sort. There's sorting item frequencies. There it is. Sort rules by equals confidence decreasing. Okay. So sort rules, and then we say by equals lift. And there it is right there. Let's add another argument here and say the decreasing equals true. And now let's return the top 10 of these. And that does confirm that we have the top 10. If you look at this right here by the lift. So you always want to look at your output. Does that make sense, Justin, right there? And I'll show that code again here in a second. It's just like remembering the syntax of some, like I know I need to sort this, but I'm then like, oh yeah, how do I do you say by equals this. So you can do sort and then by equals and pull the variable. But I don't sort rules that often, so that one jumps out of my head on how to do the syntax. It's like, how do I do it? Like notes are so good. Like you can just look and be like, oh yeah, that's how to do it. Just change it to this. So you can change it to confidence or whatever you want, just depending on how you want to sort it. And then just knowing how to get the top 10. How are we doing on this right here, Justin? I feel at this point, people should have the ability to get the top 10 rules because this analogous example is pretty much it. Like we created the rules, we removed the redundant, removed the not significant, or we went down to just the significant rules, which would remove the non-significant. Just need to change your parameters, run it on your data, and you should be good to go. Pretty analogous example to what we're doing right there. But y'all, any questions, Justin, about this? Let me know. Really good question. I'm stuck on one way to have to show my 5 rules. All right, we'll get that good question. So that is, we just did 1C. So let's do 1D now, and then we'll get to 1H here in a moment. Thank you, Justin, so much for being here and practicing along with us. 4 to 6. BS 474. Simon Market Basket. 1 biscuit. 1D. 1D might be pretty quick. Let's take a look. You should find that the top rules are Hillary Duff-Rihanna. How does that impact Ashley Tisdale? 81 listeners like these 3 artists, the set of these 3 artists. First, explain how you can get the number 81 from the support of the rule. So when you look at supports of rules, like this is the support of the rule, it's the first thing right there. By counting up the number of transactions that contain all 3 of these items, as in use codes like this right here. Okay, so I'm trying to find a rule that's not crazy long. A lot of my rules are of length 4, like lemon cookie, lemon lemonade, green tea, raspberry lemonade. That's a rule of length 4. And then it's important to know what we have right here with the data. This 155 right here represents that there's 1,555 transactions that contain all 4 of those items. Excuse me, 4 for mine. Where the 2%, basically, the 2% means out of the total transactions, which are 75,000 right there, out of the 75,000 transactions, 2% of them contain all 4 items. So what we need to do is we need to go to the transaction data, create a subset of the transaction data. We'll do it up here in the pretty space, not in pretty, over here. And so we'll create a subset of the transaction data. And we're going to have right here that the items, not the times, the items, here we go, need to have all these items in there. And so with this right here, we can grab everything. Oh, that's not pretty. There we go. And there's that. Not pretty. Not pretty. The reason I'm copy pasting is that way I don't miss a capitalization like I would miss right there. We got to close that string. We got to open up a new string. We got to close that string. We got to bring the stuff in over here. Where's my green tea? Come over, green tea. Oh, I knew I'd do that. There we go. And now we need to close that string. And last but not least, we need some raspberry lemonade. And we could do this right here. You can do that. And then we add in the last object or the last element of the string right there. And now the code reads, make a subset of the transaction data where the items must have, or the transactions must have all these items. That makes sense. Showing my 5 rule. We'll check that out here next. You got it. Oh yeah, I heard that. And so there's my subset. Let's look at the length of my subset. And the length of my subset should be 1,555. Boom! We got it right there. 474, it's, yeah. Oh, yeah, you can tell. And it all goes back to, because in 201 or 320 and stuff, we do subsets. Amanda, let me know if you have questions. We got time for a little bit more after this, especially. But if we divide by the length of the transaction data, we will get that number right there. So it's important to know where these numbers are coming from. That number right there, which is the support of the rule, represents the frequency of carts that contain all 4 of those items. Mine has 4 right here, where the 1,555 is the amount of carts that contain those items. Like, and this is what I've been getting towards in my class especially, is you should know how to interpret every single number on this screen. Any number I pick out, we go to the top rule right here and I say, what is this? and you say, if somebody has this item, and this item, I am 100%, and that item too, I'm 100% confident they will buy raspberry lemonade. Well, then what does that there represent? Well, that means 1,555 carts contained all 5 of these items. What does this number mean right here? This means the original probability of raspberry lemonade is lifted by a factor of 4.7 from its original probability. So what you could do is you could take the confidence right here of 1 and divide it by this. And now if we go to the item frequency and take the item frequency of raspberry lemonade, so item frequency of transactions, and take only raspberry lemonade, same number. So I delifted it. I found the original support of raspberry lemonade by delifting the probability. What is the coverage? I don't love talking about coverage so much, but great job on people mentioning what coverage is. Coverage is the support of the left-hand side. And think about this. We've also found that support times coverage equals confidence. So interestingly enough, because 100% of people go on to buy the right-hand side, that means the support of the rule is equal to the coverage, because if people buy this, 100% of people will buy this. So pretty interesting right there, scenario with that. So coverage is the percent of people who buy the left-hand side. Like the percent of people who buy all of these items over here is the coverage. And then 100% of the people who buy these items, 100% of them will buy raspberry lemonade, which is the confidence. And thus the coverage is equal to the support, which the support is the percent of people who buy all 5 of these items. Practice these. We did it a lot in class. If you have a specific one, let me know. We're going to talk about Justin's 1H question right here. Let's hop over to 1H. 1H says, where's 1H? Oh, where? 1H, right? There it is. Okay. Remake the rules. Call them rules mine. Let me mark this in the video. And we have time for more questions. Drop those questions in the chat. 52, 33. Here we go. Remake some rules. Call them rules.mine. Just store into that. That has a minimum support of this. That's a lower minimum support, so we're allowing more things to go through. And a minimum level of confidence. So we're just changing the in the list, the parameter equals list. Try to like commit it more to memory. Don't remove the redundant. Don't remove? Sure, whatever. Think of an artist or artists that you particularly liked back in 2011. It's getting to the point where people be like, I was 10 or something. Don't use one we've already studied, and see if any of the rules involve them on the left-hand side or the right-hand side, the left-hand side or the right-hand side. Don't mind the spelling special characters. Print to the screen 5 of the rules. If any exist, they might not. So do try to find some though. It's don't like, you should get some rules. Like, don't not get rules. Technically, the grader should count points if you write the right code and you don't get rules, but you should be able to get some rules. So we'd be doing a similar thing over here if we change our support to something like 30, and then we change the confidence to something like 40 right there. And we rerun our rules right here. It did run really quickly. So all we're doing right there is changing it. And then I think it said don't remove the redundant. So we need to remove this right here. And now we're down to our rules. We would call this something rules like mine or rules new. So these are our new rules right here. And our new rules now are 856 rules. So we get some more rules when we ease down the amount of baskets that have to contain the item, and also lower down the confidence to say we only need this amount of confidence that the rule will be followed, i.e. if people buy the left-hand side, they will go to the right-hand side. Or in this instance, or in your instance, I should say, if people listen to artists on the left-hand side, they will listen to artists on the right-hand side, which is the confidence of the rule, shown right here by confidence right there. Yep, we did 1B. I think we did 1B. Check it out. We could go back. Oh, no, we didn't do 1B. So we could go back and do 1B next. We didn't do it. We did 1C. So 1B, I'll put that next on the list. You got it. There you go. So with this right here, now you want to create a subset of your rules. So to subset your rules, let's try it. Subset of rules. There you go. There's a subset. Always run your code in those. Little bits. You want to make sure your code is running. And I think we go right here to the conditions and we sell LHS equals. I want to buy some raspberry lemonade. Always is equal. I think this is how it works. It doesn't look like it worked. Correct all my code run except when I get inspect to the subset. So if you notice right here, I don't think this is working properly. One way to tell this is not working properly is to probably store this and then take a look at the inspect on it. And does the left-hand side contain raspberry lemonade? Oh, it is. Oh, wait. No, this one does not contain raspberry lemonade. The code to get the... I got to remember how to do this. Gonna cheat. Oops, wrong one. So we want to go to subset of our rules. The left-hand side contains something. It is in the notes too. There it is. There it is. Subset equals percent. Oh, we need percent in. Has contained in it. Of course, of course, of course. Why did I forget? I know that. There we go. Let's look. There we go. Good to go. Yeah, Justin, good call. I can't believe I didn't do that. That's like the small syntax changes. And it's like, oh yeah, how do we do it again? Oh, we need percent I in percent. And you always want to look to see at what you're creating is actually the right thing. Great work right there, Justin. We do want that percent in percent, which means the left-hand side has contained in it raspberry lemonade. So there is contained in, so that's contained in the left-hand side raspberry lemonade. Now when we look at our rules, we should see that the rules all have raspberry lemonade on the left-hand side. Now to do the second condition, we're basically just going to go over here and do and, or we'll do or, because I think it says you want, like, it could be on the right-hand or left-hand side. So we're just going to go over here, right-hand side has it. Now we go to, let's look at how many rules we have. We should have more. We have 60 rules now. And the right-hand side could also have on it raspberry lemonade. So it's either on the left-hand side or right-hand side. Like this rule has raspberry cookie, lemon lemonade, and raspberry lemonade on the right-hand side. So what you want to do is you probably want to name an artist and run it right here. One thing you could do is if you want to make your life easier, you could save this as something like item and then put the item right here and then run it and then run sub, and then you can see how many things you're getting. So if I want to run it with green tea, all I have to do is change the item right here rather than 2 spots, and I can see my rules with green tea. Does that make sense right there, Justin? To be like, you could quickly manipulate and change this to something like lemon cookie by going right here, changing this to lemon cookie. So if you want to search different artists, you could just see what we have right here. So that's probably the quickest way to like manipulate that and change it. So that way you're checking left-hand side or right-hand side has it. It can't be on both. Like you got to be careful because if you do both, like it needs to be on the left-hand and right-hand side. Pretty certain we're going to get no rules because it can't. Because that would be, how does buying the item increase the probability of buying the item? And rules aren't made that way. So you can't say it has to be on the left-hand and the right-hand side. That's going to cause problems. So it has to be an or, like it's on the left-hand or it's on the right-hand side. What rules have that relationship? So at this point, I think it wants us to sort it. We're pretty much back to the previous thing right here, where now we have our subset. And whatever we want to sort by, you know, confidence, whatever it wants. You could sort your subset. We have our rules, but we want the subset. And oh, because I have the 0. There we go. And so now this would be sorted by whatever we want to sort. And we could sort the top 5 right there to get only the top 5 rules sorted by confidence or coverage or lift or count or whatever you want. How does that look, Justin? Did that help you out right there? Maybe found an artist. And if you want a good way to do it, and the one thing with the doesn't work on computer, we're going to do the plot, might need to message me on that. Message me if it's not working. Might need to take a look right there. And if you want, go to item frequency of your data and don't print. This could be too much output, but you can take a look at what's available in your data by doing item frequency, and better yet, go to the item frequency and sort it, and you could find maybe some slightly more popular artists and see how they're spelled. This would give you the top 20 artists right there if you're doing it to the artists. Yeah, exactly. And so you should be able to find something more like this code right here I'm dropping in the chat. If you run that and choose one of those artists, you'll probably find some rules. Like if one of them jumps out to you, you'll probably find it. So that is that. Whoops, did I sort it the right way? I didn't sort it the right way. Don't choose one of these. These are the lowest artists. Sort decreasing equals true. There we go. Now there's the top artist. I mean, these are not artists, but these are from transaction data, showing you the most bought items. So it's important to think about how we can use some codes to our advantage to find things like the most common artists with the item frequency code. So if you run it on one of these top 20 artists, which these are the different data set, you probably will get something that comes back important or like that you can find rules with. How's that looking, Justin? We're going to do some 1B, I think, coming up right here. But those are some good tips and tricks for doing your code. And great questions, everybody. Really good stuff. I like transaction data is its own kind of thing. It's its own kind of thing. 1B. Try to figure out how many bands have. Ooh. Funny enough, we stumbled upon a code right here, which will really help us. Okay, we got some 1B right here. So with 1B, how many bands have at least 80 listeners? So we're working with a totally different data set right now and doing similar things. How could I figure out how many people buy these items? How could I figure out how many people buy these items? So right now I'm seeing the what's. This is the transaction data. I'm working with a completely different data set. This is the, like, what does this mean? What does that mean? What does that mean right there? What is 0.100 Tuli cookie? Item frequency. It's item frequency. So what does that mean? I'm the boss. What does that value mean right there for our store? What does that value mean for our store? I'm the boss. Tell me what it means. I don't know what that value means. What's item frequency? What's that mean to us? What are you talking about? Percent of time, the item is in the cart. Amanda got some points right there. I got to throw that 1,000 points. 10% of our carts have Tuli cookies in them. Whatever that is. Sounds good to me. I'll go buy one today. So with this right here, how about we just look at the item frequency? And there's the item frequency. So now we have the item frequency right here. I've got it in decreasing order. Kind of makes it nice and neat. How could I take the item frequencies? And there might be a code within it. Let me see. Because there might be a native way of doing it. And we always check by doing the question mark. I've got another way, but I was seeing... Oh, it doesn't... You're not going to let me look at it? You're not going to let me look at the code? What? There we go. F1 did it. There it is. Look, type equals. You can change it for aid. Good to see you here. You could change it within this. Change the type equals and say relative. Oh, did that not do it? Do both? Interesting. There we go. I don't usually do it this way, though. I don't usually do it this way. Now, you probably want to sort these. Weighted equals, what does weighted do? That doesn't like that. There's not a column, so it needs some sort of column for that. I've never used that. It's false by default. I don't usually do it this way. It's not my preferred methodology to do it natively inside of it. I usually go out here and times it by the length of the transaction data. And if you look at the code, same answer. What language is this code? It is R, pirate code. So both of these are the same ways to do it right here. This is just telling us what now? What does vanilla frappuccino this mean? What does vanilla frappuccino that mean? What does that mean? That's the what. Which both of these just arrive at the same answer by finding the percent, timesing by the amount of cards, or taking the item frequency and returning it as absolute values rather than percent. Like natively, it does the relative, it looks like. I don't know why I chose both there, but natively, or originally it does the relative, but we can change it to that, and we could look at it this way. So what is that number right there telling me? What does that mean? What does that number mean to me? 5640. Number of carts that contained that item. Number of carts that contained that item. So couldn't I just go right here to the item frequency and ask what percent of the time is greater than 500? How could I figure out now? Woo, what did I do? I could figure out the mean of this. Ooh, didn't like it. Unexpected. I've got an extra parenthesis somewhere. There we go. There we go. Ooh. Oh, that's 500. There we go. So now I'm asking, think about the steps of this. I'm asking, is this item purchased at least 1,000 times? Is this item purchased at least 8,000 times? Which we might have some. There we go. Coffee eclair, popular item. Is this item purchased at least 8,000 times? Now this is just a bunch of trues and falses, and I can find out the percent of trues or the number of trues with things like sum or mean. So I've kind of shown the answer. There's only one item that's purchased at least 8,000 times, one out of our total amount of items. That'd be a longer way to find it. But does this make sense here, Amanda, on what we can do and to figure out what percent of people, like, always be looking about this, like the numbers. Like, you could figure out the answers to this by counting them with output over here, but we can also figure it out mathematically. So you want to think about how this applies to what you're doing and be like, oh, I just want to find out from this list what amount is greater than this or what percent. And so you should have it right there. What other questions are there? Because that's pretty much 1B. I'm trying to leave some open-endedness on it, but we've done a lot of question 1 right here. Exactly. R just makes it faster and easier. That's why we code. It's like, we don't need to like look and be like, we can just be like, here's the answer. Like, oh, let me just find that for you. And with very large data frames, no one really has time to go through and do it individually. No one has time to like, let me look. Okay, there's not enough time to go through and do things individually. It would take way too long. What other questions? Let's head to space. What questions are there? 201, 320, 474, 475. Maybe some 475. Got a little bit of Discord questions, it looks like. What questions are there? We did a lot of assignment. We did a lot of question 1 right now. Does R do calculus? Is it in let's look to see if R does some calculus. That's a good question. Let's see if R does calculus. Oops, click the wrong button. Oops. Does R do calculus? I think the answer is yes. R does pretty much anything we want. So does R do calculus? And let's say calculus package for R. Package calculus. Ooh. So yeah, there is. We're getting the package calculus right here. It should exist. It says it exists. We got it. Library calculus. So let's see what's in the calculus library. Oh my gosh, what do we got? Oh, whoa. So, do they show some? Mosaic calculus. Slice plot. Well, what package is this in? We're getting so many neat things right here. Whoa. Look at all the... Whoa. Look at that. That's cool. So, just looking at some different things right here. Is that the antiderivative? Functions, talking about different things here. I'm trying to find a really cool function right here. So they're make a function right here. Okay, that's closed. Oh, and then you can take the function, it looks like. Yeah, you can do a bunch of cool stuff. I wish I knew calculus better. But here's a bunch of calculus inside of R. So yeah, you could probably learn to do calculus in R pretty quickly, or like get good at it. And I should learn my calculus again by doing it inside of R. Oh, whoa, cool plot. Please work. Please work. Wow. Oh, that's the vector space, is it? So you're welcome, Justin. Yeah, it's free too, which is amazing. And so I think this is the vector space, right? So yeah, vector field. Yeah, so I mean, and this is using the pipe option here from dplyr. So you're piping in the trajectory plot of the gosh. This you know what we always ask whenever we make a graphic like this? If this works, this is gonna blow my mind. Our question is always, can we ggplotly it? And so if we can ggplotly this, this will be amazing. Like this will be the most amazing plot I've seen in a long time. Oh no, it's used the TI calculator. It actually is doing it. Oh my gosh, so it did work. So here is the vector space. It's giving little warning messages, but the plot looks like this right here. But the vector space showing the I think the length of the lines right there showing the vector space. And you could like even zoom in on it to get a better idea of what's going on in this area right here to see the vector pole or whatever it is. I don't know. I haven't done vector spaces in a long time. You're welcome, Justin, on the help right there. But there's so much cool stuff we can do inside of R. Like R is just, it has so much power to do any sort of visualizations you want. And we could just add a title to this really quickly. Like if you want to make, because I do good graphics right here. GG title. Just go my title. Yeah, a title to it like that. Should go GG title. Show me my GG. No title? You better show me my title. There's my title. And then do I have my easy center title? There we go. Easy center my title. Gender my title. There we go. There's my title centered. And there it goes right there. Appear. Yep. There's my title. And now we could run it right here. I know. Really cool, right? So now we've got our interactive graphic. We got the title on it. And yeah, I'm very big on like making graphics, expressing graphics, and you can do a lot of really cool things and do your calculus with R. So frankly, I'd probably really like it if I took a class that was like doing calculus with R. That'd be like the coolest class ever. So I don't know. Maybe I could like, I don't know. Now I want to go and retake all mathematics and just do it inside of R and be like, yeah, the computer, like, I just need to understand conceptually what it's doing. That's what's important in mathematics is like the conceptual understanding. Like sitting down and solving a mathematics problem is not the most important thing in the world. Understanding conceptually what a vector space is what's important. Like that's what we should focus on in mathematics is not the literal solving. Well, maybe I will. I mean, that'd be really cool. It's like, it doesn't matter. It doesn't matter if you can solve a derivative. It matters if you can tell me what a derivative means and why we use it. Like why you would integrate the area below a curve. We literally just talked about today in class. We talked about the AUC, which is the area under the oh my gosh, I said AKK the first time. The area under the receiver operator curve, not AIC. AKK is information criteria, which is AIC. But we talked about this, and someone mentioned integration, which is the point of it. I'm very good with calculus. Awesome for read right there. Yeah, so you would integrate this curve right here, but this is done for us. The integration of this curve, which is the curve right there. There's the area underneath it. That is the value we're searching for. So we need to know why we're getting it. It's the percent of time we correctly give the yes class a higher probability than the no class, which is basically the correct way we order the probabilities when assigning probabilities something is the yes class. So it's the higher AUC is better, meaning that the yes class has higher probabilities more often. So we need to know what it means. And it might be hard. It's a complex topic to communicate to people, like basically saying, I want to make sure if I'm selling home will buy are the most likely people to buy. So if I have a high AUC, then the people I reach out to first are going to be the ones who are most likely to buy. So I'm going to go through those people and then I'll hit my true negatives afterwards. So you don't want false positives up at the top. The yes class needs to be up at the top, the people who are actually true positives. So you put your true positives up at the top and go through them first, which makes the curve go up right here, and then it goes over when it hits true negatives. So the more true positives you hit first, the more you go up. If you go through all your true positives, you go up, 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 and then you'd get to an AUC of 1 because you've gone through all your true positives before hitting any true negatives. And the way you go through them is the order of the probabilities. So the things with the highest probabilities are the ones you go through first. And that is mathematically how it's calculated. Now you can take the derivative of the curve, but computers will do all this for you. So you have to know what an AUC is, and then you can just look at the curve and say, oh, the AUC is this. And then you just have to know a high AUC is good AUC. So knowing it conceptually and understanding what we mean when we say area under the receiver operator curve is very important because it's just a number. And we need to know why we use these numbers. What do they mean? How do we calculate them? We talked about RMSE and MAE right here today and did a small quick calculation and showed the differences between the MAE and RMSE. I should have put them, I color coded them correctly, but I reverse did them here. So yeah, it's not about knowing how to do things. It's about knowing why we do things. It's why do we do things. But with that, I got class here in 24 minutes. 2 more classes today. Great work. Yeah, Fareed. That's what really matters. It's not just like, how do you do it? It's like, why are we doing this? Why does it matter? Why do you need to know this? Why is such a good question. Ask people that. If people can't tell you why, be like, you should be able to tell me why. So with that, we'll be back here for class in a little bit. Good job, Fareed. Good job, Amanda. Bye for now, everyone. Bye.